So let's just make a little sketch of that here in our work. So this would be like A. So on our x-axis, we had our plate separation. Did I spell that right? In meters? Okay. And then on this side, we have our balancing voltage. In volts. And so our plot looks something like so. This one's probably a little closer. Just an approximate drawing. So it's a linear relationship, so we don't have to manipulate our x values to be able to use y equals mx plus b. Okay, so now what we're going to do is go hit the stat button, arrow over 1 to calc, arrow down to linear regression, which is number 4, press enter, and it's going to automatically choose list 1 and list 2 for x and y. So if you put yours in list 1 and 2, then that's good, so just press enter, and you should get your y, your a, and your b. Well, y equals ax plus b. So for our formula, let's just write down what we got. So a is 1.1164661, and then the b is negative 13.4815, etc. No? Yeah. Oh, okay. Oh, you do? That is very odd. Alright, I'll come off here a little bit. Put down line numbers and then we'll try and fix that. Okay, so what does our B represent? Your Y. Oh, yes, you're right. Y. So, where is our slope? Yeah. Why did I think it was the other? I don't know. Okay. So now it says, use the slope of the graph to determine the magnitude of the charge on the suspended mass. So now let's write out our linear formula and fit our formula into it. So this is like part B of the question now. So if we have y is equal to mx plus b, the formula that we're going to be working with needs to have voltage and distance in it. So what we're going to do is we're going to kind of work backwards. So if our force of our electrical force is equal to our gravitational force, we can say that Fe is equal to our electric field strength times Q, and we can say Fg is equal to m times G. So I'm going to kind of make my own formula relating these. So now E, we can say, is delta V over D times Q is is equal to m times g. So now let's rearrange, because we said on our graph, we set our delta V is equal to our y value, okay? And we said our D is our x value. So let's rearrange the formula so that it's delta V is equal to all that stuff. So if we rearrange it, we have delta V is equal to m times g times d, all divided by q. Pardon? Go ahead. So if it's like v times, I can show the work, over d is equal to m times g. If I cross multiply,
Yeah, I just put my v over d in brackets, so I got mg over q in brackets all times by d
m times g over q,
in bracket.
that would mean the same thing. Yeah, that would be okay. Yeah. It would only be if there's adding or subtracting that it could be different. But. Okay, so now let's fit this into our linear regression formula. So if we have our y is our delta v. We know that our x is our d. Our b for our delta v formula, there's nothing added or subtracted, so we can't put a value in there. So everything else is m times g over q. So that's our slope. So now it says, what we're going to do is we take this slope formula and what it equals to find charge. Okay? So we're looking to solve for Q, but we can use this overall formula. So let's say slope is equal to m times g divided by Q. So if we rearrange to solve for Q, we'll have Q is equal to m times g divided by slope. So our Q is equal to our mass, which was told to us at the beginning, is 3.8 times 10 to the negative 15 kilograms, multiplied by g, which is gravitational fields, or gravitation acceleration, all divided by our slope value, which we said was the 1.16, etc., times 10 to the power of 5, or you can just put it right in. So 1, 1, 6, 4, 6, 1. So let's plug that in and see what you get. So I got 3.2008, etc., times 10 to the negative 19. So 3.2 times 10 to the negative 19 coulombs, which is actually quite normal. That looks like a good answer to a charge, right? Because then that's 2 elementary charges. Okay. Okay, so that's our answer for part B. So then let's do part C. Determine the balancing voltage required when the plates are separated by 50 millimeters. So we can use our same formula and put in a new distance to solve for delta V. So we'll use this formula now that we know charge. Our mass and our gravitational stay the same. I'm going to put in a new value for D to find out V. So my mass, again, 3.8 times 10 to the negative 15 times by 9.81 meters per second squared, times that by my new distance, which is 0.05 meters, all divided by 3.2 times 10 to the negative 19 coulombs. So I get 5, 8, 2, 4, 6, 8 volts. So to sig digs, 5.8 times 10 to